Okay, I forgot to hit the button again, so I've got everything here. It's worked out bit by bit on the better quality video, which I recommend that you watch. But we can talk about this one too, and this is kind of a brief summary of what's on that video. Okay, so we've got y equals b to the x with a doubling displacement of 1. That leads us to the orange graph that we see here. The doubling displacement is here, the doubling displacement is here, doubling displacement is 1, so that the x-coordinate here is -1, x-coordinate here is 1, and of course the x-coordinate at the origin is 0. Okay, so we have on our graph of y equals b to the x when x equals 0, y equals 1, so the point 0, 1 is on the graph. Also, if we move over one doubling displacement, the y value doubles, so we double from y value of 1 to a y value of 2 as our x-coordinate goes from 0 to 1. So we have the point 1, 2 on the graph. And from that, we can determine the slope of this green chord of the circle here, and we easily determine that that slope is 1. Similarly, we go 1 unit to the left, and of course the x value will be halved, so that when we go from here to here, it doubles and gives us 1. That means the x-coordinate has to be 1/2. So we have the point -1, 1/2, and the slope between here and here is very clearly 1/2. The run is 1, the rise is 1/2. So we have slope 1/2 here, slope 1 here. We conclude that the slope of the tangent line is greater than the slope of this chord and less than the slope of this chord, so that the slope of the tangent line is between 1/2 and 1. Then we make a statement. If the doubling displacement is 1, then the value of our exponential function at x equals 0 is greater than the slope. The function has a value 1, the slope has value less than 1, so the value of the function is clearly greater than the slope. And we expect that the value of this thing, this tangent line, will be somewhere between 1/2 and 1, not all that close to 1/2, not all that close to 1, maybe around 0.7 or so. Okay, now I ask you to go on and do the same thing, assuming a doubling displacement of 1/2. In other words, mimic everything that was done here. Draw the picture, label everything, calculate the slopes, get your inequality for the slope, and then make a statement that compares the value of the exponential function at 0 to the slope of the exponential function, slope of the tangent line at x equals 0.